Okay, so in this video we'll be seeing how to implement a linked list in Python. So we'll be seeing two methods. The first one is just seeing how to implement a linked list node, and the second one will be seeing how to actually implement a linked list where we give it a couple of methods, and this method should be to append, to remove, to insert at a specific position, and we'll finally print out the linked list and see the different methods in action. So let's get started. Oh, before we get started, if you don't know what a linked list is, just Google it first. It's just basically, yeah, it's better if you just Google it and come to see the implementation in Python. We'll not be going over the definition of a linked list in this video. Okay, so let's start. So to implement a linked list node, we would start by creating a class called linked list node, and we'll give it a constructor. So it will take in self and value, as well as next node as its arguments. Sorry, and oops, sorry, let's just do this. And yeah, so self dot value will be value, and self dot next node will be next node. This is just basic constructor in Python. Now let's create the linked list class. Now, before we create the linked list class, this would be enough if we want to do everything manually. So for example, we could say node1 equals linked list node, and we can give it a value, for example, like this. We could say node2 equals linked list node, and then we can give it a value of 2, for example, and then we could give node 1 a next node because we've created node 2. So we could say node 1 dot next node equals node 2, and we cannot specify anything for node 2, and it will be none by default. Right? So this would be enough to create the linked list, but this is not very useful because everything is manual, right? So let's create linked list class where everything would be handled by methods that we'll implement in this class. So let's create a linked list, right? Let's give it a constructor. It will take in self and head if we provide it. So self dot head will just be head, and that's the only thing we need for the constructor. Now let's add some methods. So the first method we will be adding is going to be the append method. So we'll give it a value, self and value. Now let's create the node using the first linked list class that we created using this. Let's create a node, right? So, oops, sorry, I didn't mean to do that here. So let's say node equals linked list node, and let's give it that value. Now, where should this node go, right? If we don't have a head when this linked list was created, if the user didn't provide any heads, then let's create this. Let's make this node the head, right? So if self.head is none, then self.head equals node, and then let's just return the program. Let's just finish. If not, we have to traverse through the linked list to the end of the linked list and add it there. So how would we do that? Let's set the current node to self.head. Oh, sorry. And then while true, we would say if current node dot next node is none. This means while traversing through the linked list, if the next node of the current node that we are in is none, that means we've reached the end of the linked list. So we just append it there. So we would just say current node dot next node is going to be node, the one that we created right here, right? Okay, then we'll just return. If not, then let's just continue traversing, right? Current node is going to be current node dot next node. Great. Now let's create another method. Let's call this one prepend. This one, so append will add the node that we want to create at the end of the list, at the end of the linked list, and this one will create it at the beginning of the linked list, right? So we have self and value. Let's create the node just like before. So it will be linked list node, and let's give it the value. Now, if self.head is none, right, we just say self.head equals node, just like before, and then we would return. But if that's not the case, what do you think we should do? Think about it for a minute. Okay, so well, what we should do in this case is we should just reassign some things, right? So if we want to prepend this, if we want to put this node before the head that we have in our current linked list, we could just set the next node of the node that we just created, the next node attribute of the node we just created, to the self.head of the current linked list that we have, right? So we can just say node dot next node equals self.head. Sorry for the typo there. So it will just be equal self.head. So that means we're placing this before the self.head, and we want to name this the head now, right? So self.head equals node. So this line right here will make the next node attribute of the node we just created right here, the self.head, and this line right here will make the node that we just created the self.head. Hopefully that wasn't too confusing. Okay, next let's create some more attributes, right? Let's create an insert attribute, for example, right? So it will take in self, position, and value. So for this insert attribute, we're inserting a node at a specific position, not at the end or at the beginning, but we'll let the user choose a position that the node should be inserted in. So just like before, let's create the node by saying linked list node, and let's give it a value. Right now, just like before, if self.head is none, there's nothing to return, so it should probably not do anything, right? But if it's like this, then a return just return nothing, because yeah, that's not a valid input. So we could like give them an error message or something, or we could just insert it at the zeros position, make it the head, but that doesn't really make sense. So let's just return this in this case. If they want to insert it at the position 0, right? If position equals 0, then let our prepend method handle that, because it's the same thing, right? So let's just call self.prepend, and let's give it the value, and then when that's finished, we'll just return, right? Otherwise, we'll have to traverse through the linked list until we get to the position that the user wants, right? So let's set our current node, to the self.head, right? And then while count, okay, let's set a count variable equal to 1, for example, and while count is less than position, what do we want to do? We want to traverse through the linked list. So while this is true, move the current node by 1 position, right? So how do we do that? Current node equals current node dot next node, and then we'll update count by saying count plus equals 1, right? After this, we can use this current node to set the next node attribute of the node that we just created right here. So how do we do that? So one way to do this is we can just set the next node attribute of the node that we just created by saying node dot next node equals current node dot next node, right? And then we will just set the next node attribute of our current node to the node, to this node right here. So how would we do that? Current node dot next node equals node. That means we just split current node and next node with this node right here. So this came in the middle between the two. That's what inserting literally means. Okay, so now let's create another method called the delete method. So definition delete, and let's give it self and a value. Now what we want to do is, if self.head is none, there's nothing to delete, let's just return, right? If self.head.value, if the value of the head is what the user wants to delete, the value equals the value that we've been given, then what we want to do is just set the self-head attribute of the head attribute of our linked list to the next node after the head that we currently have, right? So we can just say self.head equals self.head, yeah, dot next node, yeah. So we just deleted the, we didn't technically delete it, but we're just like ignoring it from now on. We're not going to consider it as the head anymore. So hopefully that makes sense. And then we'll just return. If that's not the case, we can just set the current node attribute to our self.head, and then we just traverse through the linked list again. How would we do that? While true, we'll just say while true, and then let's just traverse through the linked list until we find the node that we're looking for. How would we do that? If current node dot next node dot value equals the value that we've been looking for. So we're checking the value of the next node that we're in. So if we find it, we'll just strip out the next node. How would we do that? We would just say, if that's true, then the current node dot next node, the next node attribute of the current node that we're on, we would just make that equal to current node dot next node dot next node. This means we'll just like skip the one that has the value equal to the one that was passed, and then just go on to the next node after that. So we're just like ignoring the one in the middle, basically, if the value of that is the same as the value that was passed. And after this, we'll just return. If that's not the case, then let's just update our current node. So current node equals current node dot next node. And that's pretty much it. To see all of this in action, it's a pretty good idea to print them all out and see what's what. So let's define a function that prints our linked list. Let's just say print linked list, and we'll give it a value of self. That's just it. So let's just set our current node attribute to current node equals self.head, and we want to print this until the end of the linked list. So while current node is not none, let's just print, so we'll use f strings here. So we'll just want to print self, no, not self, actually, we want to print current node dot value. We want to print our value. We need a dot here. And just to make it look good, let's just do this, and let's end it with an empty string so everything looks continuous. And let's just update it. So we'll just say current node equals current node dot next node. And after all of this, we'll just print none at the end. Okay, great. So now what we can do is, instead of doing everything manually, what we can do is let's create a linked list. Let's just call it LL for linked list, I guess. Let's set that equal to linked list. Let's not provide any heads or anything. Let's just leave it at none, and we'll append everything. So now LL is an object of the linked list class, right? So now if I print LL currently, what would I get? Let's see. It's just none because I haven't added anything to it. Now let me add something. So like I can say LL.append 1, and then let me print it out again. Right? Okay, what do we get? Okay, looks like linked list no text no arguments. Okay, we probably messed up. Oh, the constructor here is not full. Sorry for that. Yeah, let's try this again. Yeah, so it would show 1 to none. Good. Let's try it again with LL. Now, if we say append, for example, right, and say 2, and then if we print this out again, what should it show us? It should show 1, 2, and then none, right? Just like this. 1, 2, and then none. What if we want to prepend something to it, right? So ll.prepend, let's prepend 0, for example, and then let's just print it. What should it show? It should not show 1, 2, 0, but it should show 0, 1, 2 now, because we're prepending, we're doing it at the beginning of the list, of the linked list, right? So it should show 0, 1, 2, and then none. Great. So the functions, the methods that we applied until now, they work fine. The append works fine, the prepend. Now let's try insert. I will have to give it a specific position as well. So let's try that. Now ll.insert. Where should we insert it? Because the first argument that we have to give it is the position. So I want to insert it here between 1 and 2, right? So this is 0, this is 1. So I want to insert it here. So the position is 0. The position is 2, sorry. And I want to insert, let's just keep everything chronological. So let's just say 1.5. So I want to insert 1.5, right? So it should show 0, 1, 1.5, 2, and then none. So let's print out and see everything in action. Okay, great. So just like we assumed it would print 0, 1, 1.5, 2, and then none, right? So the insert works as well. Now let's check out the last method that we implemented, which is a delete method. So ll.delete. Now let's just print 1.5 because it doesn't look very cool. Let's just delete 1.5 and then ll.print. And yeah, let's see. So deleted it, 0, 1, 2, and then to none. So yeah, that was basically an implementation of linked list and a bunch of methods in Python. If you have any questions, please put them down in the comment section below, and I'll try my best to answer those.